Welcome to Lecture 5, Correlation Analysis for STATE100. So just to put this lecture in context, this is part of our overall discussion of descriptive statistics. So just to be clear, descriptive statistics is about when you have a sample or a population, say, conducted through a census, and the goal is to describe the data at hand. So we've covered tables and graphs, and we've also covered a basic measure of association known as relative risk based on conditional probability. For this lecture, we're going to look at a very commonly used set of measures of association for when you have two numerical variables, and also ways of visualizing relationships between two numerical variables. So we're going to look at covariance and correlation. This is part of our overall discussion of descriptive statistics. So we're going to cover a few major topics in this lecture. We're going to look at scatter plots and how scatter plots can tell us, at least visually, an intuitive understanding about whether two numerical variables are related, and that's going to lead us to a discussion on a very commonly used measure of association for two numerical variables known as covariance. Then we're going to look at correlation. Correlation is a variant on covariance that overcomes some of the limitations of covariance. Then we're going to look at when you have numerical variables, you often want to transform those set of data, and you can do a linear transformation or a nonlinear transformation. They're very commonly used because covariance and correlation, as well as other measures of association and other models fit to data, often assume linearity. So we often want to transform our data. Then in part 4, we're going to look at two very useful rules for understanding different properties of numerical variables, the empirical rule and what's known as Chebyshev's rule. So with that, let's get started with this lecture on correlation analysis.